Welcome back everyone, and today we shall be talking about XML files. We shall discuss what they are and their appearance. Then we'll discuss XML schema document files, and we'll show you how to open an XML file from your hard drive, and using the .NET framework in C#, how to read through the data in the file. Now, XML stands for Extensible Markup Language. This is similar to HTML and the way it uses tags. There is a difference between the two, however. HTML contains both unstructured information and how to format that information through the use of tags, and XML contains structured information but doesn't have tags that indicate how the data should be formatted and displayed to the user. XML's purpose is different to HTML. XML is a simple way to store or transfer smaller sets of organized data between computers or software. It may not be obvious why this is needed, but there are so many various software vendors, each have their own format to save their data in. This is sometimes called proprietary data formats. Now, to transfer data between these software programs could be simplified by a common way of representing data that humans and computers can both read easily. The benefits of this format is that it's an open format and very portable, although not as efficient for storing, retrieving and searching through the data as the more proprietary formats. There are many applications for XML. When we were looking at the data that says define, I'd mentioned it defines the structure of an XML file. But it may not have been obvious why it was also used to define a dataset. This is because the dataset is managed internally by ADO.NET as an XML document. As a result, it really simplifies the way your user can retrieve data from the database in the application. They can then disconnect from the network or internet and still be able to access the data. That would then be saved from memory into a file on the user's hard drive and then retrieved if there's no network connection. When the user connects to the network again, all the changes that they made can be saved back to the original data source, like the database, or imported into another program which knows XML. You can be very creative with this function within your applications. XML is also used for syndicated RSS feeds. So let's have a look at what an XML file looks like. So, I've created a new application called Lesson 10. I'll select the Add New Item icon from the toolbar and select XML file and change the name to cars.xml. Then the Add button. This creates a new file called cars.xml my project. Then it opens up a file into the main area of my design view. We've got a blank XML file with one line of code at the top. So this is a declaration of the XML file, and it defines the version of XML which will be used. This is mainly so that the application knows what version of the document it should conform to. Then you have the encoding style, which is the second part of this definition statement. This defines what set of characters to expect the document to be encoded in. On the next line, start with an open bracket, type car, then close bracket. Now the IDE automatically inserted a second tag of the same name, but it includes a /. So, for example, we may have a car lot here, and I've created an XML document that contains the details of the cars for sale in my car lot. I can swap this list of cars with other car dealers in my area. Generally, if another car dealer sells any car from my list, then I will give him commission. So if his customers want a certain car and he doesn't have it, he can search the database which has a list of the various car dealerships in the area and see if anyone else has that car. So if I'm a dealer in a different part of the town, I have the additional benefit of selling more cars to customers that I may not have otherwise been able to reach. So this file can be loaded into any software that each dealership uses to do their own searches. Or this document can be used on the internet, where search engines display cars over the web to people who are looking for cars. So the first thing I created was an element called car lot. This is called the root element or the root node of the XML document. XML documents have to contain one element that encloses all the other elements within the body. You'll find that system.xml and the .NET framework classes also tend to use the word node. It's just another word for element. So we'll create a single car element within the car lot root. So open tag type in car, then close tag. Again, IDE completes the tag by creating an ending tag. So there's beginning and an end. And we'll do another one. Now there's a parent with two children elements within it. The two car elements are considered to be sibling elements, and the car lot tag, which encloses those sibling car elements, is considered to be the parent. So when working with XML data, think of it like a family, parent then children, etc. So there can be sub-elements in each element and more sub-elements within those. And you can structure the levels any way you want. So elements can contain other elements, or they can contain data. Now I've created another element called make, and it contains information about the make of the car, which I've defined between the two tags. That is the begin make tag and the end make tag. So the car element contains nodes, but the make element contains text. An element can contain other elements or text or some value, but it can't contain both. It doesn't have to contain either, like in the case here of price. In this example, it doesn't contain elements or a value, so really there is no real purpose of this on its own, but elements can also contain attributes. So if I put value equals 2500, we've got an attribute called value, so the attribute value is 2500. So price equals 2500. Attributes are information encoded directly in the element definition. It's up to you when to use elements and when to use attributes. In XML, you define the structure of the document, the element names, and the attribute names. The tag name should basically describe the type of data that will store the elements, because this makes the XML document self-describing and easy for humans and computers to read. So although you have free rein here, the structure that you choose should be consistent and there should be a pattern to it. The way you define the structure of an XML document and stick to it programmatically is through the XML schema document. The XML schema document defines the hierarchy, the structure, and the data types that are used in your XML document. It's necessary for your XML document to exactly follow this definition. If it doesn't, then your application will have unpredictable results and will probably fail because it is expecting certain tag names to be used, the structure to be in a certain format, the child of the car lot to be the car, and the child of the car to be make, model, and year, etc. If this isn't followed, then in all likelihood, application would fail. Now, it's important to note that although the XML document is free form and there is flexibility there, in order to enforce the different levels of data so that it can be used in a program, you will need to define an XSD document, or type things in exactly the way that they should appear each time. The XSD document ensures that you don't make mistakes such as naming something incorrectly or use wrong styling choices, etc. So we have something called being valid, which basically means we need to be consistent. Valid documents follow the schema which they're associated with, and that defines the structure exactly. So if a document is valid, it means that the structure of the XML placement of the tags follow the way they were defined in the XML schema document. There's another test which ensures that the XML document follows the rules of XML and whether or not the document is considered to be well formed. If the XML document is well formed, it has the tags in the right places, ending tags aren't missing, the embedding isn't messed up. So the difference between being well formed and being valid is quite subtle. A valid document must be well formed. However, a well formed document doesn't have to be valid. Whilst this document is well formed, it may not be valid. I've used two different ways of defining what a car looks like, so I'll correct it. I'll paste in a new set of XML which I created earlier for my car lot. I have the concept of the make, model and the elapsed miles for both Cutlass Supreme and my Chevrolet. So 2 cars in my car lot. So my XML file will look like this. Now I'll show you how to access this XML document that we created through the use of C# and the system.xml class namespace in the .NET framework. I'll add a button on my form and create an example to see how this works. So add some labeled controls 1 to 7. This will show you how to open up an XML document from the hard drive and how to work your way through the XML document using the system.xml namespace. So save and close. It isn't so straightforward to open up an XML document and begin working with it. You need to take 3 different steps. First, open the file and read from the hard drive into the computer's memory. This you do through the system.io.streamReader class. When the file is read into the memory, then has to be converted into XML. So we'll use a class called the XML text reader from our system.xml namespace. Now once it's been passed, this means to make sure it's well formed and is actually an XML document. By the XML text reader, then we need to use an XML document object to read it into a format that it can be worked with. So double click the button and paste in some code. We'll use the stream reader class, the system.i/o.streamReader. We'll call it sr equals newsim.io stream.streamReader and pass in the constructor and pass in the location of the cars.xml file. The add symbol means we'll be looking at the current directory for the project. If we didn't use this symbol, we'd have to search for that file on the hard drive and it wouldn't be likely to find it, so we'd get an exception. For a stable application, we'd need to make this more flexible and hard code the file name, but in this case it's fine. The next step is to take that data in computer's memory and turn it into XML. We'd do that through the system.xml.xml text reader and create a new instance of that. We would pass in as an argument in the constructor the streamReader object, which was created in the previous line of code. Now we need to put it in a format that we can work with, so we need to put it into an XML document. So we created a new XML document, carlot.equal_newsys.xml document. So now we have our carlot object that we can use to pass through and work with here. Here we have to pass in a reference to the XML text reader, carlot.load, and we'll pass in the XML text reader. So then it's loaded into our carlot.object. Now that we have the XML passed, what we can do is use the inner text property to display all the contents of our document. So put in carlot.innerText and set it equal to label1.text equals text. And save and run our application. But we get a file not found exception. Now, Whenever an application is running in debug mode, a copy of the car's XML file needs to be in the bin directory /debug directory. So we'll copy our cars file and go to Windows Explorer, Projects, Lesson 10. Then we'll go down till we find the file. File seems to be missing. Think we'll go back to the Lesson 10 directory, copy it and paste it in the debug directory. Then we'll run the application again. Now, what you can see is that the data isn't well formatted. It all runs together. There's no tags listed whenever we're using the inner text property. So in this format, it isn't useful at all. So basically, we need to navigate to one of the child nodes of the root element and take information from it. So paste in some comments and we'll set the value of label to .text equal to carlot.firstchild.innerText. So basically, we'll take first child node and show its inner text and get the inner text, which would be what's contained within that first child node. And we'll run this. The first child node is our XML definition, version 1.0, encoding UTF-8. Now we'll use some navigation to get from the first child to the next child. We can do this in different ways. All I want to show you right now is how to work your way around the document. Now we have our second child node, carlot.doc.firstchild.nextSibling. So the next sibling in line should be the carlot root node. So let's do this in a text and save it. This second child node should be contained in the inner text, and this is exactly the same as the inner text for the whole document. The inner text on the document object will enable us to get straight to the information that we want and avoid any of the definition at the top of the document. We can still get access to it by using the first child method of our document object. Now we'll get a reference to the carlot object. So system.xml node carlot equals carlot.firstchild.nextSibling. So we're working with the carlot. So label 4 equals now that we have a reference to carlot. Then take the inner text of carlot and then we have label 5.text equals the first child of carlot. So carlot.firstchild.innerText. Then label 6.text equals the first child of a carlot. So that would be carlot.firstchild.innerText. Now we'll run it and look at the 4th, 5th and 6th labels. So we have a reference of car lot. We did the inner text and that would be exactly the same as the last two examples. So now we get the first child of car lot, which would be the old mobile Cutlass Supreme, and then we want to grab the first child of that old mobile Cutlass Supreme, which allows us to grab the word old mobile. This isn't really the best way to go through an XML document. This was just to show you that you can navigate from the first child to the next child, and so on, in order to go through each node and find what you're looking for in an XML document. This basically uses a family metaphor, the parent, child and sibling. This can be considered a good way to navigate through the XML document, but sometimes it can be monotonous and problems can occur as a document may not be formed exactly the way that your program expected it to be. It might still be well formed and valid, but just different than what your application expected. Another way of using an XML document is through the use of XPath expression. This is basically a companion technology to XML, and this lets you look through the XML document to find what you're looking for. So in this example we've pasted in, I'll first get an XML node list, which we'll call car lot items. I'll then use the car lot doc and the selected nodes method in order to find all the nodes of type car lot/car. So then this will return two nodes, one for Oldsmobile and one for Chevrolet. I can then work with those two nodes. There's no need for me to go through the siblings. I can just search directly and bring back all the nodes that match the criteria which I've created. With the last example, which I commented out but could find all of the nodes that match car lot, that would only return back one node for the car lot node. But this way I can search one level deeper and return all the nodes that match that sequence. Car lot, car make. The next line of code is to grab one node, which we'll call the make, then we'll return the two items, the Oldsmobile and Chevrolet, and work with the first item, item sub 0, and select a single node that is a child of either the first or second car, and grab the node that defines the make of the car. Now let's run this so it returns the word Oldsmobile. This is because we grabbed all the nodes that matched car lot car, which would bring back this and this. Then we worked with the 0 of the first item within that list, which would be this one. And we said find the element within car called make and return the value. And that was Oldsmobile. So in this lesson, we just basically learned that XML files are basically just text. You can make any format, use any keywords, and just make sure that you follow a consistent method when you're defining the data that's within your XML file. It's also very simple to navigate through the XML document in .NET. You can use the family metaphor, where you find the parent of the child or the next child, or use the XPath expression, where you're searching for elements within your XML document that match a certain pattern based on the names of the tags that you used. So that's it for today. Don't be worried if it didn't make much sense at first. It's actually a fairly simple concept and it will come together. So until next time, take care and bye bye.